Hi everyone, myself Pankaj and welcome to the next video of solving most important DSA interview questions. So in this video, we are going to solve a graph problem and the problem statement is number of islands. So let's understand the problem statement. So you will be given with an M cross n 2D binary grid which represents a map of one land and zeros water. So basically what is it saying that uh, let's say this is a 2D grid that you are given with. Now you can see here the ones and zeros are filled these grids, right? So the ones are basically the lands and the zeros are basically the waters, right? So this is the problem that you are given and you have to find number of islands, right? So what are the number of, so what do you mean by an island? So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So basically you have to consider the ones which are horizontal or vertically, not diagonally, right? You must be remembering this. You may assume all four edges of the grids are all surrounded by waters, right? So basically what it's saying that the ones are the lands and zeros are the water, right? And the edges of these grids are basically water. So you don't have to count that out, right? So let's understand the problem here. So let's say this is a grid that you are provided with, right? So basically ones are water and zeros are ones are lands and zeros are water, right? So you have to find a number of islands in this grid, and an island is basically a piece of land which is surrounded by water from all sides, and it is provided in the question that the borders or the edges of this grid are also filled with water, so you don't have to consider this outright as a land. So now how you will solve it out, right? So what you will do, let's say how many islands are there in this grid. So first of all, you can see here this is one island which is made by four cells here. All the cells are one, right? And you can notice here is that all the four sides are covered with water, right? You cannot connect these two lands because we don't have to move diagonally. It is provided in the question that we can only consider the elements which are in horizontal or vertical, right? So this is one island, and you can also see this is another island because it is also filled with water from all sides, right? And this is another island, right? So there are three islands in this grid. So how you will find this out? So first of all, what we will do, we will basically start traversing each elements in this grid, right? We will traverse to each element one by one, and as soon as we find one in this grid, what we will do, we will basically try to move in all its neighbor. Let's say you are here initially, so what you will do, let's say you find one here, right? What you will do, you will go to its vertical, let's say first. So you saw that there is water, so what you will do, you will basically return from there. Let's say you moved to its left, right? So you also saw there is water, you will return from it. Then you went down, so you saw that there is one. So what you will do, you will basically make this one as 0 and move down to this land, right? Now again when you came to this land, so what you will do, you will basically move to its all four direction. So let's say you gone to left of it, so basically there is water, so you will return from there. In its down, you also saw that there is water, so you will return from there. When you go to its right, you saw that there is land. Okay, first let's say you will also go to its up. So what we had previously done, that we had made it as 0. Why? Because we had already visited that land, right? So it will also return back from that land. And let's say when you went to right of it, you saw that there is 1, right? So what you will do, you will first make it this cell 0 and go back to that and go forward to that land, right? So here again, what you will do, you will check for all the directions. So here it is 0, here it is 0, and we made it 0 from it to its left. So the only direction is left is that is upward. So you made it 0 and move to upward. So this you find out a land here, right? Again, what you will do, you will basically check its all directions. So in its left it is 0, its right it's 0, down is 0, and up is also 0. So what you will do, you will basically return from this. So you can see that we actually found a land here, right? I'm sorry, an island here, right? So this is one island, right? So after it, what you will do, you will make a counter. What you will do, you will make a counter variable, and each time when you will return from this function call, you will increase your counter variable here, right? So you will increase your counter variable. Again, when you return back from this call after finding an island, what you will do, you will basically traverse all the elements that are remained as 0. So these all four elements has become 0, right? So let me mark it as 0. Now you will traverse this grid forward. Let's say you get all the zeros, then again you find out land here, that is 1, right? So again what you will do, you will call 4 functions that will cover all the 4 directions. Here it is 0, here it is 0, again left is 0, then down 0. So you saw that this is a single cell island. So again what you will do, you will basically increase your counter here. Again what you will do, you will traverse, after making it 0, you will traverse to the other elements of this grid. So you saw that you found 1 here. So what you will do, you will again call it for all the directions. So up, left, down, you found nothing. Then again right, so you found 1, so make it 0 and move forward to this 1. Again you will call function for checking all its horizontal and vertical directions. So you found nothing, so basically you will return and again increase your counter. So basically you saw that we found 3 islands here. This is first, that this is second, and this is third. So basically for the function that I am talking about is basically you can use BFS and DFS. If you don't know about BFS and DFS, so search on YouTube, you will find many videos on that. So what you will do, you can use BFS and DFS both, but what I am going to use is basically DFS traversal, because the code of DFS is pretty simple, right? So let's see how you will code it out, right? Uh, so we will have to first traverse this grid, right? So what you will do, let's create a variable counter to count the number of islands. So let's call it as cnt is equal to 0. Now what you will do, you will basically traverse this grid uh, is less than grid grid dot size. So basically this is row, and again you will use another loop for traversing its columns, right? So basically column goes to grid of 0 dot size, right? Then what we will do, j plus plus. Let's say you found a 1, right? Grid of I comma j is equal to 1, right? Let's say you found 1. So in this case what you will do, you will basically call DFS, right? So let's make this, and you will pass grid as parameter. Then what you will do, you will also pass I and j, and when you will return after the call, basically when we were returning from all the calls after getting zeros from all side, what we will do, you will basically we had basically found an island, right? So what we will do, we will basically increase our counter pointer, right? So here what you will do, you will basically increase your counter variable. Now let's create this DFS function. So basically it will have type of void because we are not returning anything, and let's call it as DFS, and let's call this grid, copy this grid, int I comma int j, right? Now you will have to use your base case here. Why? You can see that when we were going out of this out of the bound of this grid, so basically in that case we have to return out, right? Because these all the surroundings are water, so we have to return out from there, right? From here also, from here also, from here also, right? So we have to manage it out, right? So what will the condition for that? So let's say if your I is 0, less than 0, or you can say that if your j is less than 0, or what you can say that if your I is what, greater than grid dot size. So basically your number of rows can come until here, right? So it should not be greater than this last row, right? So basically when you will come to when your eyes point to this place, you have to basically return out, right? In the same case, when your j will point out to the column that is greater than this grid column size, basically you have to return out, right? So we are handling that, or you can say that if your j is greater than grid of 0 dot size, basically number of columns, right? In that case what you will do, you will basically return, right? Now let's say if your cell value is 0, in that case you also have to return out. Now if that is not 0, right? So what does it mean? It means you have found 1. So first of all, what we were doing, we were basically making that grid value as 0. Why? Because we have to mark it as visited. That's why we are making it as 0, so that we do not get trapped into an infinite loop, right? By visiting single element again and again, right? Okay, so we don't have to check it out because we have already checked it out as here, right, in the previous line. So basically what you will do, if these two conditions are not true, it means that we have found one, right? So basically you will make it as 0, right? Now what you will do, let's say we made it as 0, right? So what we were doing, we were calling the function all it's around horizontally and vertically. So we will have to call 4 functions in its 4 direction, right? So what we will do, we will call DFS, we will pass grid as parameter. Then first of all, let's call it as downward, right? So for downward, we are changing the row number. So we are increasing row number. So basically what I will become I plus 1 and j will remain same. Now after returning from that call, what we will do, we will call in upward direction. So I will become I minus 1 and j will remain common. After returning from that call also, what you will do, you will basically call for its right. So in right, when we are moving right, we are basically changing the column, right, and remaining in the same row. So we will keep I as same and j as j plus 1. Again, after returning from that call, what you will do, you will basically keep your I same and go in the left direction. So basically you will have to decrease your j, right? So these are 4 calls that we had to do. Now after returning from these 4 calls, we are increasing our counter pointer each time, right? So this is the code of this problem. Let's try to run this out for public test cases. Okay, we are doing a mistake here. Let's call it as int I is equal to 0, right? Let's run this again. Okay, what I am doing mistake here, int j is equal to 0, right? These are silly mistakes, guys. What the fuck? Okay, we are not returning here, so basically we have to return it out, our counter variable, right? So that's why we are getting this error. Okay, okay, we are trying to access some values which are not allowed, so we are doing some mistakes somewhere. Okay, so I found an error here because we are checking for the condition here is that I should, when I is greater than the grid size. So what does it mean? Let's say we are here, so I is basically 0 1. Okay, so let's say basically our I is here, so our I is here is basically 0 1 2 3, right? But what we are doing here is that we are checking that if I is greater than grid dot size. So what does grid dot size is basically 4, and we are checking that grid dot size, it's basically 4, means from 0 to 3, right? But we are going till 4, right? So basically we will also have to return when our grid, basically when we are at row 4 also, right? So here we have to use equal to. That's why we were getting this error. So let's try to run this out again. Okay, so you can see here our public test cases are passing. So let's try to submit this out. Okay, so our code has been accepted, and let's talk about the time complexity of this code. So you can see here we are using 2 for loops for iterating our elements of the grids, right? The time complexity of it will be big O of m cross n y, because we are traversing our each element in this grid only once, right? So we traverse this one, then we call this for checking all its neighbors, and again, and what we did, we before moving forward we made it as 0 also, right? So that we cannot come to back to this element again, right? So that's why we are only traversing each elements only once, right? That's why the time complexity will be big O of m cross n, where m is the number of rows, or you can say columns, and n is row or column, right? And talking about the space complexity, so basically we are not using any data structure for storing the elements. So space complexity is basically big O of 1, and the grid that they are providing, we are actually using that grid only, right? So this was the solution of this question. I hope you must have understood this. So let's meet in the next video. Till then, have a nice day.